Okay, so I hope the microphone is working. So thank you so much for having me here. It's been a wonderful week, very engaging program. So yeah, so I'll be talking about how can we detect consciousness in newborn infants. I'm a philosopher, but I will try to use some empirical data for make my arguments for how you can detect consciousness in newborns. So this talk's part of a larger project on theories of what theories of consciousness can predict about consciousness in infants, animals, and machines. But I will focus specifically in this talk in infants. It's also part of a larger project of how consciousness developed, not just about the emergence of consciousness, but how consciousness developed over our, at least our age as infants and children. Okay. Okay. So when does consciousness emerge in human development? So for some people, it might be obvious that infants are conscious at birth in early stages, but there is a disagreement in the field, not just regarding when conscious emerge, but whether if conscious emerge early in development or later in development. So if you look to this baby, you can see that their eyes are open. Babies at early stage, they respond to stimuli in environment. They have their open, they have wake-sleep cycle. So it seems that they might be conscious, at least behaviorally seems that they might be conscious. But there have been theoretical disagreement, but also for years, or at least in the past years, we didn't give anesthetic to children because we thought they didn't feel pain in early stages. Okay, so there was also a practical implication of not giving anesthetic because we thought that pain was something that we would learn during development. So we wouldn't need some brain development for emergence of, or at least for the capacity of feeling pain. And this could be also extended for the other type of conscious experiences in infants. Okay, so I'm interested in phenomenal consciousness in infants. So when I ask the question whether newborns are conscious, I'm interested in phenomenally conscious experiences. I don't need to go in details because I think they've already give some definition, and I use this definition in my talk. Okay, so what is phenomenal consciousness? Is this inner move you have now in your head, and that goes together with when you hear sounds, when you see faces, when you feel hunger, pain, etc. So I'm asking if infants have this type of phenomenal consciousness. So do they have experience of perceiving, feeling, acting? Do they feel pain? And as I said before, this question of pain has been particularly relevant in the case of infants. There is also a disagreement among theories of consciousness. So this is a figure from a publication last year from Tim Bain and collaborators, where they try to revise what would be the predictions of theories of consciousness in the field. I also have a paper where I discuss this, and I try to make the case that infants might be conscious at birth. So they, my own view in this matter was featured in this figure, trying to make the case for early emergence of consciousness. But you can see that the view that the field varies a lot in the predictions of when consciousness emerge. So we have those that will claim that consciousness will emerge before birth, but you can also see some other prediction about 12 months, 15 months of age that consciousness would emerge in development. Okay, so try to make. I will not argue for this view of early emergence of consciousness, particularly in this talk, but I'll try to bring some evidence that might contribute for the idea that consciousness emerged earlier in development. Okay. Okay, so another way to motivate this problem of when consciousness emerges in development is through what I call the problem of infant minds. They've also talked a little bit about this, how the epistemological problem of how can we know consciousness in others? So how can you know that we all here are conscious? We can have like verbal indications, verbal reports that we are conscious. You can also have some neurobiological markers of consciousness. You probably have similar brains as mine. So there are some indications that you all here are conscious. But in the case you don't have verbal reports, as the case of robots, suborganoids, animals, and patients in vegetative states, the questions of how can we know if those entities are conscious are very relevant. Okay, so we know we cannot observe directly consciousness in others. We cannot rely. For adults, we rely on verbal reports, but in those cases, we cannot rely on verbal reports. And in the case of infants, we also have a further problem. They are not responsive to command of following. So for instance, in the case of patients with disorder of consciousness, we can design some paradigm that we give some verbal commands, and you can see how their brains react to those verbal commands, as in the paradigm developed by Adrian Owen and colleagues, where you ask the patient to imagine play tennis and imagine walk around the house, and different areas of the brain will be activated, and this could be some indication that the patient is at least hearing the commands. You cannot do this with infants, and you cannot even train, as we do with animals, train them to push a button if they have some kind of subjective experience of the stimulus you're presenting. And you cannot also rely on past memories. We are all babies, but we have infantile amnesia, so we don't remember those. If we had those experiences, we don't remember those experiences. So what evidence can we use in this case? So my preferred method has been discussed a lot in the literature, so it's not something that I'm proposing at first place, but I'm using the methodology that have been used in animal consciousness literature, and also from disorders of consciousness, patients with disorders of consciousness. So we start with our own case, the adult brain, the adult case. So we ask adults, normal adults, when they perceive a stimulus or when they are aware of a stimulus. And from this, we can isolate behavioral markers and brain processes. From those brain processes and behavioral markers, we can infer underlying principles that connect consciousness with behavioral markers and neuromarkers. And from this, we can isolate those behavioral neuromarkers and apply those behavioral neuromarkers in the case we want to determine if the entity is conscious or not. And this is what I think is a methodology that can work in the case of infants. And through the best explanation, if you find those markers, the neuromarkers and the behavioral markers, the best explanation is that the infants also is perceiving that stimulus consciously. Okay, so what I would try to do next is show some neuromarkers of consciousness that have been developed more recently, coming from the cases of nonverbal subjects, animal and neurological patients, and see how those markers have been applied in the case of infants. So in the case of behavioral markers, although infants have many other types of behaviors, there are two behavior markers that are very relevant for infants, is a reaction to surprise and reaction to novelty. So we are born with the capacity to, when a sequence of events is happening and violates some expectations of the infants, we are capable to react with surprise. And if you habituate the infants with some stimulus and we present a new stimulus, also the infants are capable to react to this novel stimulus. So this reaction to novelty. But we know, although those behaviors have been used a lot to understand how infants' minds work, we know that those behaviors per se cannot be sufficient to the claim that they are conscious. If we identify a surprise reaction or a reaction to novelty. But it's a good start, okay? And maybe the combination of those behavioral markers with some specific neuromarkers of consciousness might bring us a more robust evidence that they are conscious. So the neuromarkers of consciousness, one way to detect, or at least to isolate the correlates of consciousness is, as I said, start with the case of adult. The adult give a verbal report. I'm seeing this dog in the environment. And if I'm seeing this dog in the environment, there is some areas of the brain that will be activated. And then I can isolate this activation as a neuromarker of consciousness. And in the case of infants, even if you disagree with the more larger questions, whether they when conscious emerge, even if you think they're conscious, we still have the problem of how we distinguish states of unconscious processes and conscious brain processes. So you might say, okay, infants are conscious, but is this infant processing these informations consciously or unconsciously? And this is not as simple to determine it, okay? Okay, we also have more recently some brain imaging methods that were developed that is more friendly to children, so have specific technology that might access brain states in infants in a more friendly way, have the infant even years, the fetal megalencephalography that you can access infants in the womb, a more friendly environment for MRI, and those the fact that this technology was developed also facilitate the way to assess those brain states. Okay, so those are the potential neuromarkers of consciousness I would like to discuss. Global violation detection, functional network connectivity, attentional blink. There is a fourth one that I think it's a very interesting neuromarker of consciousness. A new paradigm test if infants are susceptible to object substitution mask. But I would need much more time for my talk to actually go through in the details of the visual masking evidence. So I will focus in the first three markers. And I think the first one, I'll start with the first one because I think it's the most relevant and more robust one, okay? But if you want to, I have a recent publication where I discuss the visual masking, so you can just access the written version of this talk. Okay, so start with the old ball paradigm. That is an interesting paradigm, and where there is a hand.
Thanks. Sorry, just a question. How are you distinguishing awareness from consciousness? So I made the mistake at lunch yesterday of conflating these two, and it was told immediately, no. Robots may be aware of their environment, but only we are conscious of our environment. So with humans, these are kind of conflated. The babies may be both aware of things and conscious of things, but how can you distinguish between things they're merely aware of versus things they're conscious of?
Yeah, I think maybe in this talk, we could just use consciousness and awareness in an interchangeable way. Well, one way we could distinguish is maybe babies have access consciousness to one phenomenon, but to one stimulus, but don't have phenomenal consciousness okay? But I'm using this here purely interchangeable. Okay, so one of the theories of consciousness that claims this, for instance, this global old ball paradigm, that is a global workspace theory, they probably will reject the distinction and I think consciousness is just access consciousness. Okay, so the old ball paradigm. So the old ball paradigm was developed first in patients with in comatose patients with disorders of consciousness, and was first proposed by Tristan Benkenstein and his group. So the idea is we can learn different sequence or a certain sequence of different sounds, okay? And for one sequence of sounds, we might learn this, we can learn this automatically and unconsciously, and for the other sequence, we might need consciousness. So I go now to distinguish those two sequences. So one sequence we call local old ball or local regularity. So the example would be a sequence of 4 sounds, 3 sounds with high pitch and 1 sound with low pitch. For instance, beep, 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 boop, beep, 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 boop. So the first 3 sounds are equal, and the fourth sound violates your expectations, because if you hear a sequence of similar sounds, we expect the last sound to be the same. And if the last sound is deviant, it shows you some violation of expectation of this pattern. But we are also capable to learn a global regularity. That means a sequence of sounds that repeat, creating a pattern of sounds. So beep, 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 boop, beep, 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 boop, beep, 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 boop, beep, 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 boop. If the last one is beep, 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 this last one will violate the sequence of sounds that I was expecting. Although beep, 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 beep is just a sequence of similar sounds. So in itself, this sequence, there is no surprise, but there is a surprise if you consider the patterns of sounds you're expecting, okay? Okay, so this paradigm was developed first to test consciousness in patients with vegetative states. So patients usually have 2 types of brain response to this. A mismatch negative response that usually just indicate a type of an unconscious response, but followed by a marker of conscious response. So the first response is followed by a later wave. That's a P300 P3 complex that it has been claiming in the literature as evidence of consciousness. Okay, and this type of response you can see in patients that are not capable of verbal communication. Okay, okay, so we don't see. So in the case of the local old ball, just going back to the local old ball, in the case of the local old ball, I don't need to be conscious to be capable to have a response of a violation of expectation when I'm hearing the first violation of expectation. So for instance, beep, 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 boop. So I don't need to be conscious to be capable of automatically generate a response of a violation. But for the global old ball, I need consciousness to learn this, require consciousness to track those complex sounds that is repeating. Okay, so this pattern of sounds, it seems to require consciousness. So what is the marker here? Global violation of detection, reaction with a response of violation of expectations together with the global old ball. It's a marker of consciousness. Okay, so what a group of neuroscientists does, they apply this paradigm in infants. So they found first attentive 3-month-old infants capable of react to the global old ball. So they engaged the 3-month infants with a video, and they learn the local audible, they learn the global audible, and they react with the P300 complex to the global audible, okay, indicating a similar brain response as adults would have. And they also find this in infants at the first week of life. So newborn infants also are capable of the same response. And this, as you can see, the type of learning paradigm they developed. You have sounds that are similar, and then you have a deviant sound, a global and a local paradigm, a global and a local regularity task. And what they did, as they could not be sure that the video will engage the children, the infant, during the task, they correlate this with heart rate variability. So high heart rate variability is a prox for being awake, low heart rate variability is a prox for being sleeping, okay? So, and what they show is just the infant that has the high heart rate variability together with those two responses and the P300, this might be a marker of conscious. They are conscious perceiving the stimuli, okay? Okay, my assessment to this evidence is that probably is a significant evidence, is a robust and significant evidence. And if you think that there is no indication that we can detect global audible unconsciously, and if there is no evidence we can detect global audible unconsciously, this is a marker of that infants at least is doing this task consciously, okay? Second marker, functional connectivity. So the functional connectivity is the presence of two types of brain networks that works reciprocally, but in a kind of uncorrelated pattern. So we have one network, there's a type of inner network that usually is involved in self-referential tasks or self-referential states or even resting states, called the default mode network. And you have an external network that usually is a network that is activated when we are involved in focus our attention in a task related to some external stimuli. So those two networks, they work in an uncorrelated pattern. So one is activated, the other one decreases. When the other one increases, the other one decreases. Okay, so when you are attending to a stimuli in the environment, the inner network, the inner awareness network decreases, and vice versa. Okay, and what we know from the literature on disorder or patients with disorders of consciousness is that this anti-correlation pattern is disrupted in cases of patients that are unresponsive and also disrupted in anesthesia. Okay, so it seems that this anti-correlation might be at least the presence of this anti-correlation might be a marker of consciousness. And what they found is that infants at birth already show this connection, this connectivity, and this reciprocal correspondence between those two networks. It's interesting that they didn't find this in infants, in preterm infants, just preterm infants at term age equivalent when they achieve the natural age of, or if they were full term. But it's already there, and it's already working reciprocally. Okay. Okay. So I think for this brain networks, I don't think this is exactly a marker of consciousness, but might be a marker of capacity for consciousness. This tells us that the infant brain is already very early, at least have the function connectivity that might be required for consciousness. Okay, so at least we can make a case because we know from the literature with disorders of consciousness that we might have case where the internal awareness is present without consciousness and vice versa. So we cannot claim actually this is a marker of consciousness, but I think it's at least the capacity for consciousness. So the third neuromarker is comes from a phenomenon that that reflects some sort of limitation of our brain of the amount of information we can process at a time. So we call this attentional blink phenomenon. So this, we cannot focus, there is some limitation of amount of processes, or at least of targets we can process at a time. So when the cognitive system is focused their attention in one stimulus, we might not be able to attend a second stimulus if the second stimulus is present short after that stimulus. So usually 200 and 500 milliseconds after, if you present another stimulus, if you're if you're attending consciously and focus in one stimulus, you might miss the second one. We call this attentional blink. There is some sort of competition of the amount of information the brain might be capable of attending. And if you are consciously perceiving the first target, you miss the second. But you have to be consciously attentive to the first target. If you're not consciously attended, you're not susceptible to this phenomenon, okay? And there is evidence of attentional blink phenomenon in infants. The first evidence was for 5 months, 5 months age, with a longer duration. So infants are not susceptible in the same way as us. They need a little bit more time, interval, and between one stimulus and another stimulus to be able to get the effect. But they are capable to be susceptible to this attentional blink phenomenon. And if you correlate this with the P300, that is this slow wave that has been identified as a marker of consciousness, you can make the case, and in adult cases the same. You have the attentional blink and you have the P300 response. So putting those two pieces together, you can make the case that infants are susceptible to this attentional blink phenomenon. And more recently, there was another study that shows 3-month-old infants also are susceptible to this kind of phenomenon. And so usually, although the infant brains already respond in similar way as the adult brain, it's slower than adult brain, okay? So the P300 is not a P300 in the case of infants, it's a P400 or P600. So the amount of seconds we need for the response to show up is longer than we have in the case of adults, okay? Okay, so this is the first time that was a first study by Sid Kuder and collaborators 2013, was they first established the capacity of infants to show this P300 phenomenon. This has been discussed in the literature. I have a previous article where I discussed this, whether this is a marker of conscious or not. Proponents of the global workspace theory have suggested P300 as a mark of consciousness. And I think Megan will also discuss this. A recent paper by Tim Ben and collaborators also have been discussed, the P300 global effect that they called, so the P300 associated to the global old ball as a marker of consciousness. So although there is a discussion whether the P300 actually is a marker of consciousness, because there are some cases where patients were showing P300 response without being conscious. And there are cases where it seems that the patient is conscious but is not showing the P300 response. So seems not being sufficient and seems not to be necessary. although there is some discussion if the P300 actually is a marker of phenomenal consciousness per se, I think is a pretty robust evidence that infants have similar profile of response of consciousness as in normal adults. So the idea here is, although we might questioning the validity of this response, one discussing the literature, maybe the P300 is a post-consciousness effect. So after I consciously perceive a stimulus, I have this type of activity that is related to some sort of cognitive capacity. But it's pretty impressive that infants at early stages are already showing this type of response. So although there is some discussion, I think the status is still at least in competition for potential tasks for infant consciousness. Okay, and there's my assessment also. I think I just said what is in this slide. Okay, so the further case is for fetal consciousness, and if we are conscious before birth. Okay, so one important piece related to fetal consciousness is whether when in our development we have the structure that are required for consciousness. So there is some convergence among neuroscientists that we need a thalamocortical system for consciousness. Is not a completely agreement, but is a very strong agreement. And if this is right, and thalamocortical system just developed around 26 weeks of gestation, there is no interest to search for consciousness before 26 weeks of this gestation. But then the question is, after 26 weeks of gestation, are we conscious after that? So although there are some agreement that thalamocortical system is necessary, or that is required for consciousness, there is no agreement on when the thalamocortical system become active, have the type of connectivity with the brain that would be actually reflect their role in consciousness. So even if this structure is necessary, there is no evidence of functionality of the thalamocortical system around 26 weeks of gestation. So we might need to combine this with other evidence. So usually it seems around 35 weeks of gestation, the thalamocortical system already working. And another point regarding fetal consciousness, that even if the thalamocortical system is active around 35 weeks of gestation, maybe the one chemical might sedate the fetus and might prevent the fetus to be conscious. So even if you have the structure, we might not have consciousness might not be deployed, might not actually exercise in that capacity. Okay. So one interesting and surprising result is that we found a similar global old ball response in infants. I'm going, okay, how much? 5 minutes, okay? Okay. The global old ball before birth, we find similar response at 35 weeks of gestation, the same result, the same reaction to the global old ball. Okay, so this was a study from the similar group that did the global old ball at birth. They also found this at 35 weeks of gestation. So, and this also correlates with the high heart rate variability. So similar results. So if the global old ball supports consciousness at birth, it might support also consciousness at 35 weeks of gestation. Okay. One question we might have is how put this evidence together with development of the human brain. And we show a similar image from Alison's talk on the development of human brain. So have this information that certain areas will achieve their synaptic peak before other areas. So we know that the visual cortex and auditory cortex and the premotor cortex also, the motor cortex also will achieve, will be developed, will be functional before the cognitive areas, okay? So a plausible view we have at least until recently was, okay, we start with a kind of sensory and motor consciousness, and then we have cognitive consciousness. However, there are some evidence that although the cognitive areas are not completely maturated, they might already be functional in early stages. So probably one metaphor that, for instance, Ghislaine Dehaene-Lambert has been using is think about the infant brain as a slow train compared to a fast train that might be an adult brain, okay? So it might be, some cognitive capacity might already be there, but might be in a slow motion, okay? So they are immature, but they are functional. And the global ball show this because the global ball require some sort of cognitive capacity. Okay, conclusion. I'll just say one slide of my conclusion and not go for the other ones. So I think conversion evidence from the studies of cortical response to global ball, brain networks, and attentional blink tends to support the presence of conscious and newborn and potentially in late-term fetus. More conclusive evidence will require stronger neuromarkers of consciousness, which may require, in turn, better grounded theories of consciousness. I have some discussion. I will just not have time to go among theories of consciousness, why I think this type of evidence show some conversions regarding theories of consciousness. And I'll just close with my open questions. Okay, so open questions. What does a test for consciousness in infants look like? Is the P300 global response a good candidate? I think it's promising, but it's still early stage. I think still need some more development for confirm this as a test for consciousness in infants. What does development of consciousness in the infants suggest about development of consciousness in an AI system? So could you think about AI system as a system that will develop consciousness? So we emerge consciousness at a certain point. So think about the system as a system that is in process, in the developmental process. Can evidence of consciousness in infants help to evaluate theories of consciousness? So how can we do the other way around? You use the evidence to test the theory, the predictions of the theories. And what are the ethical implications? I am a bioethicist too, so I'm very concerned about the implications for early emergence of consciousness, but also for developing conscious AI systems. Thank you.
Yeah, thank you very much for the talk. I think it's a really important ethical problem in many cases in medicine, for example, let's say end-of-life decision-making, clinical neurology. I feel that many of the things depend on contrasts. No, you could put me under deep anesthesia, and I might lose the P300. But if you go even in the human case, a patient with severe damage to the brain or ongoing epilepsy, it might not be possible to compare my brain with an intact P300 to the patient where it's lacking. And I think it becomes even more salient when you try to find consciousness in other minds, animals, invertebrates, machines. So I'm curious to hear what you think could be a way to find these markers outside of the human brain. You know, what could be a marker in machines? Because surely you can't use my brain to predict the consciousness of a machine.
Yeah, I think this is a marker. The P300 is a marker of a neurobiological system. There is evidence that this marker is present in, at least, for instance, in primates. So it's not a specific marker for human brain, okay? But it's a marker that is for a biological system. It's not a marker for a system that probably don't have a neurophysiological system. But one thing you said, so in the case of anesthesia, so you lack consciousness. So if you lack, and if P300 is a good indicator of consciousness, and you lack P300, this might correlate with the fact you lack consciousness during anesthesia. Okay, and this is the same for patients in comatose state or vegetative state that lack consciousness. The question is whether, I'm seeing your question maybe two steps. One is whether P300 is actually a good marker, or P300 like whatever is the version in the infant case is a good marker for for humans. If we can apply this marker in other systems, like in other biological systems. And the further question is whether this marker is a good marker for machine consciousness or non-biological system. I don't think it's a marker for non-biological systems. What we have in the theory is a connection between the P300 and the global workspace theory. So we have a theory that connects this marker with a kind of a certain structure in the brain. And if you think the structure could be, if the machines can have a global broadcast or global workspace, this could be the marker. I don't know.
Okay, we have to keep moving, actually.
Okay.
Thank you.